Hi, welcome to the session. We're going to discuss 5 solid questions on algebra in this session. Let's start with the session. So this is the first question. You can go through this question, attempt it for 2 minutes, and then look at the discussion that we're going to have. Let's go through this question. For a magic show, n people numbered P1, P2, P3 and so on were standing in a row with positions numbered 1, 2, 3 and so on till n in a ground. After the show got over, people who were standing in the odd numbered places left first, and the remaining people shifted to the nearest previous numbered place that got vacated. In the second cycle of exit, again the people who were standing at the odd numbered places left and the remaining people shifted in the manner given above. This process continued till there was only one person left in the row. If n is 5000, then what is the number of the person who was left in the end? Okay, the best way to approach these kind of questions is to take a small number and see what is the logic that comes out of it. And then you can extend the same logic for n being 5000. So I'm going to take a small number like 10. Let's say n is equal to 10. Let's see what happens. If n is equal to 10, we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 as the numbers of people who are there initially. Now, after the first exit, we will have 2. So 1, 3, 5, 7, 9 will be out in the first exit. So after that, we will have 2, 4, 6, 8 and 10. So these are the ones which are going in the first exit. Let me just put like this. First exit. These are the numbers which are out in the first exit. Okay. After the first exit, we'll have 2, 4, 6, 8 and 10. Now in the second exit, these ones will go off. 2 will go, 6 will go, 10 will go. So these are the ones which went in the second exit. So after second exit, we will have only 4 and 8. Now when we go for the next exit, 4 will go off, right? So 4 will go and 4 is going in the third exit. So when 4 goes in the third exit, after that, so after third exit, we will have only 8. Now here if you see, the numbers which go in the first exit are odd numbers. The numbers which go in the second exit are numbers which are multiples of 2 to the power 1. That is, the highest power of 2 in those numbers is 2 to the power 1. Okay. If the number has more than 1 2, it stays back. Right? If the number has only 1 2, it goes in the first exit. Then in the next round, if the highest power of 2 in that number is 2 square, it goes off. In the next round, we have a number that's a multiple of 2 cube left. So what we can understand from here is, if the number is a power of 2 and the highest power of 2 that you have within your range, that is the number that is going to stay back. Okay, in this case, it is 8 that is staying back. That is the highest power of 2 that you have from 1 till 10. So the funda is very simple. A power of 2 is going to stay back, and the highest such power that you have in the range is the number that is going to stay back. Okay, so in this case, when I have n as 5000, I'll have to just find the highest power of 2 that is there within that range. The highest power of 2 that is less than 5000 is 4096. So 4096 is the one that is going to stay back. Let's go to the next question. Okay, you can take 2 minutes to solve this question and then look at the discussion. If P, Q, R are integers such that P, Q and R are between minus 130 and 130 and P plus Q plus R is 90, then what is the maximum possible value of P, Q and R? So this builds on a fundamental concept which goes like this. For positive real numbers A and B, when A plus B is constant, A into B is maximum when A is equal to B. Now this is a concept that has been discussed in the concept classes when I discussed inequalities in modulus. You can prove this on the basis of AMGM inequality. Now I'm not going to prove that. I'm going to build on the top of this. So take this part. P plus Q plus R is 90. And if it is given that P, Q, R are only positive, then to maximize P into Q into R, I should try and distribute this 90 as equally as possible among all these three. So I can distribute it as 30, 30, 30 and multiply that. That should give me the maximum possible product. But in this case, P, Q, R can also take negative values. So let me see if I can exploit that particular aspect to increase the product further. But my product has to be positive. So I'll have to make sure that exactly two of them are negative. I cannot have one or three negative. In that case, my product will become negative. So I can have two of them negative and probably the third one will be positive. Let that be R. Let me see what is the greatest positive value I can give for R. So P, Q and R should be less than 130. So the maximum I can give for R is 129. It has to be less than 130. We are looking at integer values. So I can take this to 129. And when I do that, if I have changed R value to 129, I've also affected P plus Q plus R, right? So what is the increase here? The increase that you see here is 99. Now I'll have to nullify that increase by creating appropriate negative values for P and Q. So to nullify that plus 99, I'll have to do a minus 99. And I'm going to do it such that these two values are as equal as possible. So plus 99, I can split it as minus 50 and minus 49 on the negative side to make sure these two numbers are as close as possible. So now what will be the result in that case? This will become 30 minus 50, that's minus 20. 30 minus 49, that is minus 19. So we can conclude that maximum value of PQR is minus 20 into minus 19 into 129, which is basically 20 into 19 into 129. That comes to 49020. So answer for this question is 49020. You can take 2.5 minutes to try this question. It could look like a slightly complex one. So take 2.5 minutes. Within that, if you can solve it, it's great. And then you can get back to this discussion. So let's discuss this one. If x to the power 2 into log x to the base 3 whole square plus 7 into log x to the base 3 minus 5 is 81. And the product of the roots of this equation is given, where P and Q are co-primes. What is the value of P plus Q? Okay, I could see that we have log x to the base 3, log x to the base 3 here. So let me replace that with something so that I'll have a proper quadratic in the power. So let's do that. Log x to the base 3, if I'm going to take this as, let's say, m. Let's take that as m. That will also mean that x is equal to 3 to the power m. Now I'm going to replace this. Let's rewrite it as x to the power 2, and this is going to be equal to m. So 2 into m square plus 7m minus 5 is equal to 81. Now instead of x, I can put 3 to the power m. Now there's more reasons to do that, because on the right hand side you can see we have 3 to the power 4. So instead of x, I'm going to replace 3 to the power m. So this will become 3 to the power m into 2m square plus 7m minus 5, and that's equal to 3 to the power 4. As the bases are equal, I can equate the powers here. So that will give me m into 2m squared plus 7m minus 5 is equal to 4. So this is a cubic equation. Let me just take this m inside. It will become 2m cubed plus 7m squared minus 5m is equal to 4. Now this could have 3 values for m, as it's a cubic equation. When I try to find out the roots, I could get 3 different values for m. There could be identical values also, but I'll get 3 roots here. So let me take the 3 values as m1, m2 and m3. They need not be distinct, but you can take that you have 3 roots here, m1, m2 and m3. Now if I'm going to get 3 different values for m, which will satisfy this equation, then when I substitute here for 3 to the power m, I'm going to get 3 different values for x as well. So I will have x1, x2, x3 coming from m1, m2 and m3 respectively. So those are basically roots for this equation. That's what we're looking at, right? We are supposed to find out something about p plus q when product of the roots of this equation is this much. The roots of this equation could be x1, x2 and x3. Now product of the roots is given here. So if I multiply these 3, I should be able to get this. Now if you want to write this in terms of m, x1 will be 3 to the power m1. So let's write it down. x1 is 3 to the power m1, x2 is 3 to the power m2, x3 is 3 to the power m3. This is basically product of the roots, and that's equal to how much? An expression is given here that's equal to this much. So I could rewrite this as 3 to the power minus p by q, right? So this should be equal to 3 to the power minus p by q. So minus p by q should be equal to the powers I can add here. It will be m1 plus m2 plus m3. I'm equating the exponents on both sides because the bases are 3 and 3 on both sides. m1 plus m2 plus m3, that can be taken from here. This is basically sum of roots, right? Sum of roots in a cubic equation. How do you find out? Sum of roots will be negative of the coefficient of m square in this case, which is minus 7, by coefficient of m cube, which is 2. So this is equal to minus 7 by 2. Minus p by q is minus 7 by 2. So I can conclude that p by q is 7 by 2. So because we have given that p and q are co-primes, we can directly say p's value is going to be 7, q's value is going to be 2. We are supposed to find out p plus q, that is 7 plus 2. The answer for this question is 9. Let's move to the next question. You can take 2 minutes for this, see if you can solve this question, and then come back to the discussion. A graph is said to be reflected on a line when the line is treated as a mirror exactly halfway between each point on the graph and its corresponding reflection. If the graph of f of x is equal to x squared plus 4 is reflected in the line y minus 5. Okay, first let's take this. F of x is equal to x squared plus 4. Let's try and get the graph for that. Let's say the coordinate axis is like this. Let this be the x-axis, let this be the y-axis. We are supposed to figure out the graph of f of x is equal to x squared plus 4. F of x is equal to x squared plus 4. First, let's start with x squared. X squared is going to be a U-shaped graph where the bottommost point will be at the origin. If I'm going to take x squared plus 4, this is going to go exactly 4 units upwards, right? So f of x is equal to x squared plus 4 would be a graph like this, where the bottommost point will be here, and that will be y is equal to 4 line. Okay. Now this is reflected in the line y minus 5 is equal to 0, which is basically y is equal to 5 line. So let me put that line here. Let's say this is our y is equal to 5 line. So I'll have to reflect this on this line. So what will happen? Anything that is below that line will get reflected on the top, and anything that is above that line will get reflected on the bottom. So what will happen to this graph? This graph would become something like this. When it gets reflected on this line, it will become something like this. Now the key thing to notice here is the line is y is equal to 5, but the bottommost point is at y is equal to 4 line. So when it gets reflected, the topmost point will be at y is equal to 6 line, because the mirror should be equidistant from the reflection and the original graph. So as the original graph's bottommost point is 1 unit away from the mirror, the reflected graphs will be 1 unit away from the mirror as well. So that should be y is equal to 6. Great. So this graph is going to go down like this. Now, and then the reflection is reflected in the line y plus 3 is equal to 0, which is basically y is equal to minus 3 line. So that's going to be somewhere down. So let's take it like this. Let's say this is y is equal to minus 3 line. Now when I have to reflect, then whatever is there below this will go above, and whatever is there above that line will come below. So let's take that one. Let's say it is going to go down like this. Now where will it go down? I'll have to check that, because this is y is equal to minus 3. Right now the topmost point is at y is equal to 6. So there is a distance of 6 plus 3, 9 units here. So from here 9 units it has to go down. So the reflected graph will go down 9 units from this line. So this is y is equal to minus 3, 9 units. If it goes down, then this will be y is equal to minus 12 line. It will be at y is equal to minus 12 line. So our white color graph that we have drawn here is g of x, and the yellow color graph that we have is our f of x. The white color one is g of x. They are going to be graphs of same shape. I've drawn them as slightly broader and slightly narrow, but their shape is not going to change. Their shape will be the same. Only changes, they're going to move up and down. Okay, don't just look at my graph at the exact shape. The shape is going to be exactly the same. They're just going to move up and down. Okay, so the yellow color graph and white color graph are only going to differ by the fact that they're going to be at y is equal to 4 and y is equal to minus 12 respectively, the bottommost point. Okay, now let's try and answer this question. Which of the following is true? F of x is equal to g of x plus minus and all is given. So this is g of x. G of x is at minus 12, at y is equal to minus 12, the bottommost point. And for f of x, the bottommost point is at y is equal to 4. So from minus 12 to 4, it is 16 units movement. 16 units of upward movement is required for this white graph to become that yellow graph, right? So g of x plus 16 should be the answer. So f of x will be g of x plus 16. That will move g of x graph 16 units upwards. That's how we solve this question. Let's move to the next one. This is a pretty interesting question. You can take 2 minutes, attempt this question, and then look at the discussion. How many integral values of x satisfy the inequality given below? 22 by x minus 7 into x minus 5 and so on. So first let me get this minus 1 to the left side. So that will be 22 by x minus 7 into x minus 5 plus 15 by x minus 7 plus 1 less than or equal to 0. Now I'll have to take LCM here. So if I take LCM, that will be x minus 7 into x minus 5. Let's see what we'll get in the numerator. 22 plus 15 has only x minus 7 in the denominator. So I'll have to multiply it with x minus 5 plus 1 has only 1 as denominator. So that will get multiplied with x minus 7 and x minus 5 less than or equal to 0. Now this being an inequality, I cannot say I can take this on the other side and make it 0, because I need to know the sign of this. Inequalities will reverse if you're going to multiply both the sides by negative value. So as I don't know the sign of this, I cannot multiply this side and this side by x minus 7 into x minus 5 and say I'm cancelling this one. That's not possible. So how do we resolve the situation? What we can do, and that's how we solve these kind of polynomial inequalities when they are coming as p by q forms. So what we do is we multiply numerator and denominator by the denominator to make sure the denominator gets squared and hence it cannot be negative. Let's do that. So if I'm going to multiply numerator and denominator with the denominator, so the whole thing is going to get multiplied by x minus 7 into x minus 5 in the numerator and x minus 7 into x minus 5 in the denominator as well. So what will I get? In the denominator, I will get x minus 7 whole square into x minus 5 whole square. Now that can never be negative, right? So now I can say you could multiply the left side and right side by the denominator and get rid of the denominator, and that will not affect your inequality. So I'm just going to strike out the denominator here. So we can get rid of the denominator. Now what are we left with? We are just left with the numerator less than or equal to 0. Let's simplify that. So we have x minus 7 into x minus 5. Let's try and simplify what we have got here. That's going to be 22 plus 15x minus 75 plus x square minus 12x plus 35 less than or equal to 0. That is x minus 7 into x minus 5. Let's see what will come out of this. I have an x square here, so x square. And what about coefficient of x? I have plus 15x minus 12x, so that's going to be plus 3x, and the constant term minus 75 plus 35, this is plus 35, minus 75 plus 35, that will be minus 40 plus 22, so that's going to be minus 18 less than or equal to 0. So minus 18 and 3, I can write it as 6 into 3. So x minus 7, x minus 5, I can write it as x plus 6, x minus 3 less than or equal to 0. Now I'll have to take critical values here. For that, I equate each one of them to 0 and see what will be the value of x. So x minus 7, if we equate to 0 and take the value of x, x will be 7. In this case, it will be 5. In this case, it will be minus 6. In this case, it will be 3. Now let's plot that on a number line. So minus 6 is the smallest value, so let's put that here. Minus 6, then 3, 7 and 5. 3, 7 and 5. Coefficient of x to the power 4, that is the greatest power of x that we have here. So coefficient of x to the power 4 is going to be positive, which means the rightmost side here is going to be positive. So let's mark that. The rightmost side is positive and this interval is going to be negative. This interval is positive, negative, positive. These signs tell the sign that the graph will take in that interval. So in this interval, the graph will be negative. In between 3 and 7, the graph will be positive. What is the question asking us to find out? The question is asking us to find out when this expression will be less than or equal to 0. So we are interested in the negative ranges. Equal to 0 is also fine. So we can choose these endpoints. But if you look at what we have got in the original question, we have got x minus 7, x minus 5 in the denominator, which means you cannot have x being 7 or x being 5. In that case, the denominator will become 0, the expression will go undefined. So that will eliminate 7 and 5 from our solution. Now let's see how many solutions we have. We are looking for integral solutions. So minus 6 to 3, all integral solutions including minus 6 and 3, that is 6 plus 3 plus 1. We have 10 values here, or you can think of it as 6 negative values, 3 positive values, and a 0, 6 plus 3 plus 1, 10. And between 7 and 5, you cannot take 7 and 5, but you can take 6, which is there between them. So that is 1. So 10 plus 1, we will have a total of 11 values here. So answer for this question is 11. With that, we have come to the end of the session. I hope it was useful to you. Please like this video if you find the session useful. It helps us to keep ourselves motivated to do these sessions every day in the morning. I'll catch up in the next session.